Okay, so here we are back at the board.
Yep.
And we're going to talk about what might be going on here.
Yeah.
It turns out 1 plus the square root of 2 has a friend. And that friend is 1 minus the square root of 2. Look like pretty similar numbers, right?
Yeah.
Do either of you remember what this number was approximately? 1 plus the square root of 2?
Like 1.414.
Well, that's the square root of 2.
So 2.41.
Okay, so the square root of 2 is approximately 1.414.
Yeah.
So 1 plus the square root of 2 is approximately 2.414. And 1 minus the square root of 2
is 0.414.
well, that's the square root of 2 minus 1.
It's negative. It's minus 0.414.
Okay. 1 minus the square root of 2, which is 1 minus 1.414 is approximately minus 0.414. Okay?
Yeah.
So these numbers together have a very interesting property. And you're going to see later on in math lots of times where numbers get paired with a very similar looking number.
Yeah.
And at the end of this, I'm going to show you how this happens to the Fibonacci numbers.
Cool.
Alright? Let's look at what happens when I add these two numbers together. What is 1 plus the square root of 2 plus 1 minus the square root of 2?
Well, the square root of 2's cancel out. And
Okay.
you get 2.
Okay. So when I add these, I get 2. So here I get an integer. Remember James Tanton's problem was asking if powers of this ever got close to an integer?
Yeah.
Well, when I add this in, I get an integer right away.
Yeah.
Okay, well maybe I just did that. Maybe that's just a trick. Okay. But I want to show you what happens when I look at the next power. So 1 plus the square root of 2 squared, which is 1 plus the square root of 2 times 1 plus the square root of 2. Okay, now when you multiply these, this is just like multiplying numbers. So if I did 16 times 16, for example, that's 10 plus 6 times 10 plus 6. So I multiply the 10s, then the 10 times the 6, then the 6 times the 10, and the 6 times the 6.
Yep.
Okay, so here I'm going to do 1 times 1, which is
1.
1. 1 times the square root of 2, which is
Square root of 2.
square root of 2 times 1, which is,
Square root of 2.
and the square root of 2 times the square root of 2, or the square root of 2 squared, which is
2.
high five. So when I square this, 1 plus the square root of 2 squared, I get 3 plus 2 times the square root of 2.
Cool.
You see that?
Yep.
Now let's see what happens when I square this one. I'm going to let you do this one out all by yourself, okay?
Alright.
Go ahead.
So, we start out with a 1 as before. Then, it's plus minus the square root of 2. And then, again. And then we get minus the square root of 2 times minus the square root of 2, which is 2. Or is it? Minus the square root of 2 squared. What is that?
Good question.
Minus the square root of 2 times minus the square root of 2.
What do you think?
Well, you could take a minus 1 out of everything.
Okay.
It's this, which is minus 1 times 2, which is 2, minus 2.
All right.
So this would be minus 2.
What do you think? Minus the square root of 2 times minus the square root of 2.
Well, if we multiply 2, we could do it by doing a simpler we could figure it out by doing a simpler problem like minus 1 times minus 2.
Okay, what is minus 1 times minus 2?
Well, we haven't really talked about multiplying minus numbers.
Okay, have we?
Yeah, a minus times a minus is a positive.
Oh yeah? What do you have here?
A minus times a minus is a negative, but this is irrational.
Oh, interesting. Okay, well, what happens is you have a minus 1 here, so this is minus 1 times the square root of 2 times minus 1 times the square root of 2. So there's actually 2 minus 1s.
So those cancel out.
Well, they multiply together,
Yeah,
and they produce a positive 1. So this is a plus 2. Okay, so this, when I multiply it all out, I get 3 minus 2 times the square root of 2. Okay?
Still pretty similar.
They are still pretty similar. And what happens when I add them together?
Well, sort of the same thing when you added them here.
Okay,
You get 6.
I get 6,
Which
is an integer.
Yeah.
Okay.
Yeah.
So it seems like, even though we've only done 2 examples, when I have powers of this plus powers of this, and I add them together, it seems like I end up at an integer. Now let's go see what that means. Let's go back to the computer, okay?
Yep, alright.
Alright, can you find a cap for that? It dropped on the floor.